Step 3. Creating the 3D geometry. Click the 3D View button to display the 3D view of the editor. The 3D view currently does not display 3D elements. There will also be a message that there are no 3D elements. You can simply OK that message to proceed. You can see a GL string next to the origin of the coordinate system. G stands for Global Coordinate System, and L stands for Local Coordinate System. As default, these two coordinate systems are located at the same point. In the editor window, click the button to the right of the 3D Script button to open the 3D script in a separate window. The two buttons produce different behaviors. If you click the 3D Script button, the 3D script will be displayed in the editor window in place of the parameter list. If you click the button to its right, it will open in a separate window. Click the Help ArchiCAD GDL Reference Guide menu item. Go to page 33 in the AC10 GDL Reference Guide and find the description of the cone, C-O-N-E, command there. Select in the PDF file the line containing the syntax of the command and copy it to the clipboard. Go back to the ArchiCAD window and click into the 3D script window of the object. Paste the GDL code into the 3D script window. H means the height of the cone. R1 and R2 specify the radius of the cone at its base and at its highest level, respectively. Alpha 1 and alpha 2 are inclinations at the end surfaces of the cone relative to its vertical axis. In the case of a normal cone with a pointed tip, alpha 1 and alpha 2 are both 90 degrees, and R2 equals 0. The center of the cone's base will be located at the origin of the local coordinate system, and its body will be generated toward the positive direction. Modify the GDL code to the following. Enter the following command in the next line of the 3D script. This command shifts the position of the local coordinate system 0.06 meters along the z-coordinate of the local coordinate system in the positive direction. Now, activate the 3D view. You can see that the global coordinate system origin and the local coordinate system origin are now not at the same location. The cone is already generated, and we moved the local coordinate system origin to the top of the cone so we can script the next element within the GDL object from that position. In the GDL reference guide, find the description of the cylind command, page 31. Copy its syntax code, cylind H, R, to the clipboard. This command will create a cylindrical shape. The height of the shape will be the value defined by the H parameter, and its radius is defined by the R parameter. The center of its base will be located at the origin of the local coordinate system, and its body will be generated toward the positive direction. Go to the 3D script, and in the next line, paste the syntax code. Modify the code to the following. This way, the radius_leg parameter will be used to specify the radius of this element. Enter the following command in the next line of the 3D script. We again move the position of the local coordinate system 0.05 meters along the z-axis in the positive direction. Enter the following command in the next line of the 3D script. The next element we need to create is the leg portion of the table. Enter the following command in the next line of the 3D script. In creating the leg portion, we use this new variable in the cylind command. Enter the following command in the next line of the 3D script. With this instruction, we again shifted the local coordinate system. At this point in time, we are located at the desired bottom plane of the tabletop. If you activate the 3D view, you can see where the local coordinate system origin is located. The reason we did that is because we need to create an upside-down cone. The next two commands will explain why this is necessary. Enter the following command in the next line of the 3D script. The mul_x, mul_y, mul_z commands invert the direction of their respective axes of the local coordinate system. Activate the 3D view and see that the z-axis now points downward. The x and y axes point toward the same direction. This basically has an effect as if we mirrored the local coordinate system to its xy plane. Since elements are always created relative to the position of the local coordinate system, a cone will now be generated downward, which was our purpose with this step. Enter the following command in the next line of the 3D script. ArchiCAD will display an error message saying that you have a parameter error. Error messages are important because they tell you that you must correct your script, otherwise your object will not behave correctly. Many times the correct model is not generated until you fix the error. In this particular case, the problem is that the last two parameters, the angle parameters, must be greater than 0. This will generate the upside-down cone. Activate the 3D view to see the result. As you can see, the upside-down cone adjoins the top of the leg portion. This is why, in step 16, we moved the local coordinate system by the value of the leg, height underscore leg, plus the height of the upper cone, 0.04. Enter the following command in the next line of the 3D script. The del command undoes coordinate transformations. By coordinate transformation, we mean any command that alters the position, direction, or unit length of any or all the local coordinate system axes. The parameter 1, following the command name del, instructs the program to undo one coordinate transformation. The last such transformation was the mols -1 command. This is what is undone in this step. By activating the 3D view, you can see that the local coordinate system returned to its state prior to the mols -1 coordinate transformation. Enter the following command in the next line of 3D script. This will create the tabletop. Its height will be the value specified by the thickness underscore top parameter, and its radius will be the value specified by the radius underscore top parameter. Here you can see the usefulness of giving descriptive parameter names. You look at the command and know exactly what it does. With this last command, we have finished creating the 3D model of the table. Enter the following command in the next line of the 3D script. When the del command is followed by the top parameter, it instructs ArchiCAD to delete, undo, all coordinate transformations. This will result in the local coordinate system origin to again return back to its position of being coincident with the global coordinate system origin. Activate the 3D view to see the whole model. As you can see, the whole model is complete. Also, the global and local coordinate systems are coincident.